Alright, we're going to move on to 1.7. 1.7 is going to deal with inequalities. Inequalities. If you guys remember inequalities, there are those symbols that look like this, like that, and that. So 1 is less than, greater than, less than, or equal to, greater than, or equal to. I'm not really worried if you guys remember what they're called. I just need you to remember what they mean. So if you notice, these two are inside these two, and we'll talk about that or equal to in a second. But these mean this, they don't mean, here, let me show you. Let's say if we start with something like this. So that's just telling us that the number on this side has to be bigger. That's all it's telling us. And then on this side, it has to be smaller. Even though this has a different orientation, still means the same thing. It closes to the smaller side and it opens to the bigger side. And the same thing is going to go for these. This is still going to be the bigger side. This is going to be the smaller side. Same thing goes for this one. This is going to be the smaller side. This is going to be the bigger side. The only difference for these two is this portion here. This is really important because that means or equal to. So that means this might be the bigger side, this might be the smaller side, or they might be equal to each other. Equal to each other. Equal to each other. You can think about it as if your parents asked you do you want to go to Disneyland or Six Flags? You're not going to go to both. You have to pick one of them. Where if they said we're going to go to Disneyland and Six Flags, that means you'd go to both of them. That or statement is really important in mathematics. And it's really important in the real world as well. Because there's a difference between you going to 2 parks versus just one of them. So for example, this here, let's say 5 greater than 5. That is definitely false. 5 is not greater than 5. But let's say example 1, example 2. This is true. Again, and the reason why is because here 5 is not greater than 5. 5 is equal to 5. And then this one gives you're not satisfying the greater part, you're satisfying the equal to part. And that's where the or is important. It doesn't have to satisfy both. It's impossible for a number to be smaller than a number and equal to it at the exact same time. So in this case it's true, in that case it's false. So that's really important to remember, because that means that this statement is true if there's an equal to part. If there's no equal to part, then it's definitely false, because 5 is not greater than 5. So you want to just be careful when you see that notation. And that's going to be important once we start graphing these. And then we'll graph them here. And once we graph them, we have to remember a couple of things, but we'll get to that. But the main important thing, bigger side, smaller. Bigger, smaller, bigger, smaller, or equal to. Smaller, bigger, or equal to. That's what you have to remember. Because when we're looking at a number line, say if you guys remember just a regular number line, 1, 2, 3, -1, -2, -3. The numbers on the right are always bigger than the numbers on the left. Like for example, just comparing, we're just going to compare 1 and 2. The number that's bigger is on the right. The number that's smaller is on the left. So always remember that. Bigger, let me write that here somewhere. Just something to note. Bigger numbers on the right. Smaller numbers on the left. So just something to keep in mind when it comes to graphing these. So let's look at an example of graphing them. But again, we're not just going to look at just numbers. Alright, a little small noise in the background. Had to pause the video real quick. Alright, but of course, this is an algebra course. We have to look at variables with them. So, for starters, we're going to look at something like, let's say x is greater than 2. So we have to be able to graph this on a number line. But like I said, this is the bigger side. That's the smaller side. So this is telling us, so a lot of people like to think about where this is pointing, and I don't like that. I just know this side's bigger, that side's smaller. So that means x are all the numbers that are bigger than 2. So remember, we're trying to satisfy this inequality. We're trying to make sure this inequality is true. So the way to make that true is all the numbers that are bigger than 2. So if we look at 2 over here, all the numbers that are bigger than 2 are 3, 4, 4.5, 2.5, 2 3/4, 3 1/4, 3 3/4. Like anything in this direction is bigger than 2. So when you make your graph, the only number we have to reference is 2. But I can't actually, x cannot be equal to 2. So that's why I put an open circle here. Because if I plug in 2, that would mean 2 is greater than 2. And this is false. So I can't have that. So that means I'm going to have this open circle here at 2. But then I know all the numbers that are bigger are always on the right. So that would mean my solution if I use a graph. There's also different ways to write this notation. There's something called set notation, and there's something called interval notation. So this would be the graph. Then this is how set notation would look like. Set notation always uses braces. And this is the way we would write it. So we have to start with what variable we're looking at. We're talking about x. And then you draw this vertical line that implies such that. This means such that. So you can think about it saying, here's a variable x. I'm going to tell you something about that variable on this side. That's what that, like x such that, meaning I'm going to tell you something about this x on this right hand side. And what I'm telling you about that x is that it can only be the numbers that are bigger than 2. Again, it seems weird. It looks like I just plugged that in there, which I did, because you can use words or you can use symbols to imply that. And that symbol is saying everything that we need. There's also something called interval notation. So that's set. And then we have interval. Interval notation is a little different. So interval notation, you always want to write from least to greatest. In this situation, is left to right. But when we start looking at, later on, we're going to look at domain and ranges. We're going to have to look from like down to up. But the main thing is from least to greatest. So, and you have to write this from least to greatest. So we know the smaller numbers are always on the left. So that means this entire interval is starting at 2, but it continues to the right, to the positive side forever. If you guys remember how to write a symbol like that, that means infinity. But then there's this extra part that we have to remember for interval notation in particular. For interval notation, whenever you're using parentheses, this implies something, I like to say, not included. I think I spelled that wrong. Included. Where brackets imply included. And what I mean by that is that whenever you see parentheses, that's going to go hand in hand with an open circle. So let me do that again. Parentheses will always go hand in hand with open circles and goes hand in hand with these two symbols. Whereas for brackets, let's say we're looking at brackets, will always go hand in hand with a closed circle. And I'll show you guys right now what a closed circle is, when you see a closed circle. And it goes hand in hand with these two symbols. And the main thing is that it has the equal to part. That these equal to parts right here. So again, that's going from, this is intervals notation. This would be graphing, and this is the actual inequality. So it's these three things that go hand in hand. 1, 2, 3. Set notation, I mean, you just input that one here. So let's look at another example. So now this example will be, let's say, x is less than or equal to -2. Again, we only have one number to reference. That's -2. But remember, now it has this equal to part right here. So what that means, when you're graphing it, you're actually going to have a closed circle. So that closed circle means that if I actually were to use that, if I plug that into this x, so again, this is where x used to be. When I plug that in, that's actually a true statement. -2 is less than or equal to -2. It's not less than, but it is equal to it. So that's why we have a closed circle. But then again, we have to resort back to this. Smaller, bigger, smaller, bigger. So x is smaller than -2. Then we have to go back to this idea. Bigger numbers on the right, smaller numbers on the left. So here, 1 is smaller than 2, hence it's on the left. 2 is bigger, so it's on the right. With negatives, it switches. The -2 is actually smaller than -1. You can think about it as owing someone $2 versus owing someone $1. So one is getting closer to being actually having money, where the other one's still in debt, which you don't want to be in debt. So that means numbers that are smaller are on the left. So now, when I write my set notation, same thing. I have my braces. the variable in question is x. I'm going to tell you about that x, and that x has to be strictly less than or equal to -2. And now interval notation, like I said, from least to greatest. So now I'm not going to start here because the smaller numbers are on the left and they're in the negative direction to the left forever. So that implies a negative infinity. And then the greatest number is at -2. Because that's where it sort of stops. This one started at 2, but not including 2. This one ended at -2, but it actually includes. That's what I mean by not include and include. Because this has the equal to part, hence it's included. This didn't, hence it's not included. And this isn't an equal to. This is just me pointing something out. Hopefully that didn't get confused. Again, I haven't finished the interval notation on this one yet, because I wanted to talk about this portion. And something I forgot to add to this one was, or to this top one, what usually every time you use, or kind of goes hand in hand with these, for infinities, you're always going to use parentheses. So that means for this infinity, parentheses. For this infinity, parentheses. That's just always true. But now we have to look here. Open circle implies parentheses because this too cannot be included into this statement. Because if you did, it would be false. So you would close that there. But here, this -2 is actually included, because if I plug that into this statement, it's actually going to be true. And that's where it goes hand in hand with the bracket. So, just remember, main thing, smaller, bigger, and how we graph these. It's the main important idea to get from this part. But now we actually have to try to solve these inequalities. This is just a quick review of what inequalities are. So just keep that in mind. Now let's go on.